Okay, today's section, the quadratic formula, 5.5 from our textbook. You should be familiar with the quadratic formula already from geometry, but we're going to use the quadratic formula to gain a better understanding, a deeper understanding of how you actually use it. So we're going to use it to find real roots of quadratic equations, and those roots will be able to lead us to locating the axis of symmetry. So with that, let's do a little proof of where this quadratic formula comes from. So what you're looking at here is our standard form of our quadratic, ax squared plus bx plus c equals 0. And we have been, if you recall, in the last couple sections, talking about how you change from standard form to vertex form, and from vertex form to standard. So if we were going to solve this quadratic formula, notice there's no numbers in, so it's in its generic state. We would have to apply the same steps we've been using to complete the square in solving and getting it ready to be in vertex form. So to do that, our first step would be to divide both sides by that a term. If we're not sure whether that a term is 1 or not, we would want to make sure by dividing everything by a. From there, that c over a term is our number, our constant. So we should move it to the other side to get out of the way to help us prepare for completing the square. So if we move that to the other side, that would be a subtract c over a on both sides. From there, this is where we would fill in our blank. Here we put a blank square, but we would have to move that perfect square number into that blank slot. And remember, in math, to keep things balanced, you would need to add that same thing to both sides. From there, we have basically done half of the middle term, b over a, take half of that, so that'd be b over 2a, and squared it. So that would be b squared over 4a squared. That is our perfect square value, because remember, a, b, and c in our original equation are numbers. That is the number that we've added to both sides in that blank position. From there, if that left-hand side is a perfect square, you should be able to write it as a perfect square binomial by taking the square root of that number you added on both sides. Now, this right-hand side is a little more complicated in that you had a fraction that had a denominator of 4 over a squared, and you had a fraction that only had a. So common denominator there would have to be that 4a squared. So we're going to have to take this fraction, c over a, and we are going to have to multiply it by 4a on the top and the bottom. So when we do, 4a times c would give us 4ac on top. 4a times a would give us 4a squared. Now the two fractions are exactly alike, and we can combine them, and that's where the b squared minus 4ac all over 4a squared comes from. From here, if you go back and take the square root of both sides, because our goal again is to solve, which means to get x by itself, we would get the square root of the left-hand side, which is a perfect square, and we'd get the square root of this number combination on the right-hand side. Now, we should already know that the square root of a square is just whatever you have underneath, so that's what we're seeing, x plus b over 2a. On the right-hand side, we know whenever you take the square root of a square in an equation, we know you need the plus minus to give both the positive and the negative value. But our b squared minus 4ac, the only thing that really changed is the denominator was a perfect square number. So what is that one number that multiplies by itself to give us 4a squared? And that was 2a. So we simplified the denominator is all. From here, if we want to finish solving to get x by itself, we would move that b over 2a to the other side by subtracting. That would now give us negative b over 2a plus and minus the square root of b squared minus 4ac all over 2a. But that's like two separate fractions, so there's one more step you can do to clean it up, and that gives you what you should have memorized as the quadratic formula. X equals the opposite of b plus or minus square root of b squared minus 4ac all over 2a. Now, just going to point one thing out. When we go back and we had our, right here in this line, when we had our x plus b over 2a, that's as close to vertex form as we're going to get. And remember, we set our x value, our x number. This is like x minus h. And before, we said that was our line of symmetry. So that's giving us an idea of what our line of symmetry is going to be on every single one of these. So take a good look at this line. Let me highlight it here. Because this is as close to vertex form as you're going to get, and then that x minus h value would be hidden right here. And so I think we're going to be looking at our vertex for our, not our vertex, our equation for our line of symmetry right there. We'll note that a little later as we go. So double check that in your thinking, the simplest form of a quadratic equation comes from the original standard form of a quadratic. And remember, the key is that you're remembering that standard form is ax squared plus bx plus c. That equals 0. And the a values, the b values, and the c values are really numbers. So when you look at this formula, that's a number, that's a number, that's a combination of numbers, and that's a number. So that right-hand side should turn out to be all numbers if you just do the order of operations and your calculations accurately. So if you do not have that memorized from geometry, please make sure you start working on it, because you definitely want it memorized. It will be that x value, that solution, that root that we've been talking about. Now also, we've been solving for zeros. Once we factored, we found out that those zeros really are where they fall on the x-axis, so they're called x-intercepts. And now we're going to add to that, they are really our roots and our solutions. So you're looking at 4 names for the same things. And the directions could ask all. So it says solve, find the solutions, find the zeros, find the roots, find the x-intercepts. It could just switch it up and you would be doing the same process, the quadratic formula, or factoring if that's easier, whichever method is good. The reason we threw the quadratic formula in because we found out that not every single problem can be factored with whole number solutions. So we now have the quadratic formula as another choice to help us solve for our solutions. Then, as we just talked about, we will have x equals the opposite of b over 2a will always be the axis of symmetry from standard form. So if it's the axis of symmetry, you know the x value is your x value of your minimum or maximum point. Because, quick visual, if here is our parabola and we drew that line of symmetry, we know that that xy ordered pair that's sitting there has to be the same as that x equals number on the vertical line. So we're looking at, if this is the axis of symmetry, it is also the shortcut for finding the xy ordered pair on our min-max point, vertex point. So something else to memorize as a shortcut. All right, so now if it says use the quadratic formula to solve, job 1, is it in standard form? Okay, so that's the first question. Is it in standard form? If it's not, then you will want to rewrite it. I believe this one is in standard form. So step 2, identify your A, B, and C values along with their signs. So be very careful. So our A value is sitting right here, our B value is sitting here, and our C value is sitting right here. So if you need to do along the side of your paper, well, you know, A equals 1, B equals negative 16, C equals negative 36, then that's what you do before you start your quadratic formula. So here we go. You'll do the calculation, I'll do the setup, and we would start. Our variable is x, so x equals the opposite of b, plus or minus the square root of b squared. Okay, so you're doing, and if you just want to write b squared, now remember any number, positive or negative, when squared, so that's why I've left the negative sign out here, will be a positive number. B squared minus 4 times a times c, and c is a negative, you need to include that, all over 2 times a. Do that math, and you will have your two solutions for this problem. Now, in class, we will talk about how you can plug that into your calculator all at once, and maybe use a little shortcut on your calculator, but that's what you want to be able to do. So you would then have to next apply and make sure you analyze the square root part first, get that number, and then you would have whatever 16 plus or minus that number is, all divided by 2 left to analyze. So make sure without the shortcut on your calculator, you're doing order of operations, which is power first, and then you would do your multiplication. And those three numbers have to be multiplied together first. All right, moving on. If you were giving something like this, 5x squared plus 1 equals 7x, and it says give the exact value and the approximate to the nearest hundredth for this equation, you have a couple choices. Number one, again, it's not in standard form. So you would rewrite it, get it in standard form by moving that 7x to the other side, move the 1 down, and set it equal to 0. You could try to factor on this one, but I do believe that it's not going to be factorable with whole numbers. So your next step would be to identify your a, b, and c and start plugging them into the quadratic formula. So x equals the opposite of b, that would be a 7, plus or minus the square root of b squared, which is 49, minus 4 times a, which is 5, times c, which is 1, all over 2a. 2 times a this time is 10. So again, if we're going to do this without a calculator, you're doing the multiplication inside first because we already squared the 7. 4 times 5 times 1 is 20. 49, take away 20 is 29. So we got 7 plus or minus the square root of 29 all over 10. Square root of 29 is not a nice number, so we can't break that down. 7 and 10, there's no reducing. So this is our exact value, and then you would just go to your calculator and make sure you do both parts. 7 plus the square root of 29 divided by 10, and then 7 minus the square root of 29 divided by 10. It will not be always the same plus and minus number. So you could get two different solutions along the way. So do that to approximate to the nearest tenth, and you're done. So we're going to work through these, and also remind me to show you how we put in the quadratic formula on our calculator. So we should be good to go.